Alright, so we're going to change the base of logarithms. And the reason why it's really useful is because some of you on your calculator only have a log base 10 button. Right? You can't do log base 3, log base 6, either log base E, we'll talk about that later. But you don't have a log base 2 button. So you're going to have to change the base so that you can get an approximation for a logarithm that does not have a whole number, right? And I'm going to show you how to change the base. First thing I'm going to do is I'm going to go ahead and derive that equation right now. This is going to be weird, but it's good to see. And let's see if I can execute this properly. Okay. So the idea here is I'm going to take something in log base b, and I am going to express it in log base a. So like for instance, if I had something in log base 3, I would be able to write it as log base 10. I can change the base from log base 3 to log base 10. Here we go. So the first move is I go ahead and let L equal log base b. Okay. All right. L is just a variable. Yeah. What this allows me to do is it allows me to say that b to the L is equal to x. Remember, we have a property of logarithms. Remember we say that b to the L power is x. Remember b to what power is x? So that's all I'm doing. I'm writing that. I'm saying b to the L power is x. It's just another way, right? So I'm writing that logarithmic equation as an exponential equation. Okay, if that's true, then it must be the case that log base a of x is equal to log base a of b to the L. So see, so all I did was substitute b to the L for x in this equation, right? Right here, I just did a substitution. This also is okay. Now I'm going to go ahead and pull the L out, right? So I'm going to say that log base a of x is equal to L log base a of b. And I'm going to go ahead and just rewrite this up here. So I'm not doing anything but rewriting this equation up here because I'm about to do I only have 2 more moves left in this derivation. I'm deriving a formula for you guys right now, which is some college level. Oh, come on, kid. Right. So now I'm going to get L by itself. I'm going to isolate the variable L by dividing both sides by log base a of b. Log base a of x divided by log base a of b is equal to L. Okay. What is L? Remember at the very beginning we said that L was log base b of x. So I'm going to substitute that back in. And I get the equation that says that log base a of x over log base b, log base a, I apologize, of b is log base b of x. So what did I just do? I just changed the base. I said, hey, imagine if I have log base 3 of x, right? I just said, well, I can express that as log base 10. So it's log base, that would be log base 10 of x over log base 10 of 3. And we're going to use that formula. So that'll make a lot more sense. But that's a derivation. It's good to see this is what mathematicians do. So if you were a mathematician and that was your job, you really wouldn't do very much with numbers during the day. All you would do is mess with equations. There are no numbers involved in this. All just variable quantities. And then what you would do is you would find ways to represent variable quantities in different ways, and then you would put it into a computer. And essentially mathematicians are computer programmers. In order to get a math degree, you have to take at least 2 computer programming. And you get it to do. All right, so we're going to go ahead and apply that formula. I'm going to write it over here again real quick because we're going to use it down here. First of all, actually I'll write it down after we do this, okay? Now, cool thing is on your calculator, you have a button. That right there, log base 10, right? Your button on your calculator is log base 10. Look at yourself. They rent them in the library for $10. Alright. So this is log base 10. Of 3 squared, right? I can hit my enter key and it tells me that's approximately 0.954, right? .954. Fantastic, right? And in all reality, when you're actually calculating logarithms, 8 out of 10 times, maybe even 9 out of 10 times, you're going to wind up with a decimal answer, right? So when we're solving logarithmic equations, that's the next place where we're going, your answers are going to be decimals a lot. You're going to have to enter it in the calculator. So you might have to, if you have one of these calculators, you are probably going to have to do the change of base formula in order to calculate that. If you have a newer calculator, it actually has a function in it where it can change the base. It's not a big deal working either way. So let's look at changing the base right now. Okay. Yeah, I'm gonna first start by going. If I have log base b of x, I could write that in terms of a different base by writing that as log base a of x over log base b, log base a, I keep doing that, log base a of b. That's our change of base. We're going to use it so that we can put this into our calculator. Right? What I showed you was the log base 10 button. I don't have a button on my calculator that does log base 3, although for some of you there's a way to do it, and I'll show you. So let's go ahead and change the base. So that is going to be equal to, alright, so check it out, log base 10, so we're just going to leave it as log, of 3 squared, so that's my x, right? So that's x over log base 10 of, and now I'm going to put b here, my base. I'm going to worry about b. So that's what's going on, okay? So that's how I change the base. I take what I can choose whatever base log I want, usually 10, right? And then I'll put what's inside my parentheses in the log of my numerator, and I'll put what my base is in the log of my denominator. Okay. How did I know that? Huh? 3 to what power is 3 squared? People are forgetting less than 8, but it's okay. Remember that that's how we calculate logarithms, right? So this one actually has a whole number to answer. But let's go ahead and go to our calculator and let's put that in there, okay? So let's go ahead and calculate log base 10 of 3 squared divided by log base 10 of 3. Right? That's what we have written there. And indeed it is 2, right? So that's 3 to what power is 3 squared? 2, right? Alright. Now I'm going to show you, for those of you that have a newer operating system on your calculator, I'm going to show you how to not change the base and just go ahead and put that in your calculator right away. So you're going to hit the math button. And if you have one of these, there's a good chance it doesn't fit. I don't think mine, I'm pretty sure mine, I think you can put it on there for mine, but I haven't, no, it's not on there. So, but all of the newer ones do. Mine are very old. I've had one for a long time. But if you go up, you'll get there faster. It's the command second from the bottom. So going up gets you there faster. It's the log base command. I do. All right, so I hit enter, and look at that. It brings up a logarithm, and I can put the base in, and I can put what I'm taking the log of. So in this case, we do log base 3 of 3 squared. And indeed, those two things are the same, right? So the calculator has told me that what I did was actually correct. Awesome, thank you guys. All right, let's move right along. Now, we absolutely have to change the base for this one. So let's change it. So again, I want it to be log base 10. I will put what the log is, right? So I'll put the x value in my numerator, and then I still have log base 10 here, but now I'm going to do it to the base, okay? And then if we calculate this, this is going to be an approximation. So we're going to do, well, all I have to do is go up here. I can copy this in, because all I needed to do is change that value, right? And it turns out to be, if I'm rounding to the thousandths place, approximately 3.17. Right? Perfect. And you could use your log base function to see that that's the same. You don't necessarily need to change the base, but you can see that if you don't have the log base function, you're just doing one extra step. Okay, just one extra step. Okay, moving right along. We are not going to do any of this stuff. It's just showing that these properties are true, and you know what? They're true. So we're going right along to 4. Skipping all that extra stuff where we're having you guys do things that I'm really, that kind of stuff is, it's college level. So we'll do some of that, we'll do some stuff, but I'm going to pick and choose what we're going to do.
What is LN?
I'm about to tell you.
Oh, because I've been seeing that in my physics class.
In your physics class, well now, the veil has been lifted. There you go. LN. The terminology that I'm going to use for that, it's called a natural log, okay? So I'll say it's natural log or LN. I'll use those two terms interchangeably for it. Natural log or LN, right? So sometimes trees are cut down by humans in the forest, right? And sometimes they just fall on their own. The ones that fall on their own are natural logs. Thank you. I'll be here all week. All right. No, what is a natural log? Natural log, so natural log of x is the same thing as log base e of x, right? So remember, earlier on, we talked about Euler's number very briefly. I put it in the calculator. It's approximately something like 2.1875187, and then it changes after that. It's just a number that it turns out helps model. So it's a logarithm that occurs more often naturally in nature, right? Log base 10 works really well with our number system because our number system is base 10, but the world doesn't necessarily follow our rules. So it's true. We model the world, not the other way around. We can't manipulate the world. We can only find ways to describe it. We have to work within the laws of the world. The world doesn't work within our laws. Right? Okay. So what this is log base e. So e is a number, right? It's a number. It's an irrational number, but a number nonetheless. So if that's true, then what is natural log of e? If natural log is log base e, then what would natural log of e be? It is log base e of e. And what does that equal to? Well, you're right the first time. It's 1, right? Because remember we say e, so what power is e? Well, 1, right? Because that's the only way to to raise something to an exponent and get the same thing would be to raise it to the first time. We are not going to make a conjecture. We kind of just did, actually. So, there we go. Now we know what natural log is. We're not going to calculate all these things in our calculator, because I don't want to just push a bunch of buttons from class. I want to actually get this work done. So,
Natural log of log base 1.
It's log base e.
For e.
Let's look at it. So e, remember back in, I forget which lesson it was. Ooh, I was wrong. 718. I said 817. It's approximately 2.718. Let's leave it at that. Okay? That's what e is. Why? All right. So now we know what e is. We understand that natural log is log base e. we can put that in our calculator, forgot. So what if we if we put ln, natural log of, and then we can also get the number e from our calculator. And this should be 1, right? And it's 1 because natural log is log base e. All right. So we're going to go ahead and apply our properties of logarithms to natural logs. So I just want to show you guys, well, number one, it's good to get more practice with using properties of logarithms. And number two, it's also, I just want to show you that it works the same with natural logs as it does with any log base anything, right? It's all it is a difference of notation. You use the same properties no matter what. So let's do this, right? Always, when I am condensing a logarithm, I'm going to go ahead and take this and express it as a power inside my logarithm. So natural log of 4 is going to be equal to, whoops, my bad. Oh, I've been writing. We had equations and we moved back to expressions, and I wasn't doing it very fluidly. All right, so always when you are writing logarithms as a single logarithm, the first thing you're going to do is take any coefficients that are on the outside, and you're going to write them as powers inside of your log. Then, I'm just going to go ahead and write that 1/3 to the third power as 1/27. All right, because 3 times 3 times 3 is 27. And now I've got this deal, and I'm going to write it as a quotient. Right? Remember, I'm using the property that tells me that if I have a log of x over y, that is the same thing of log of x minus log of y. So I'm using that particular property. Okay. So this is going to become a natural log of 4 times 27, right? Because if I have 4 over 1 divided by 1 over 27, I flip and multiply. It becomes 4 over 1 times 27 over 1. And 27 times 4 is 80 plus 28, or 108. And now I'll use the property of logarithms that says that if I have a log of x times y, I can write that as the log of x plus the log of y, which turns out to make this natural log of, so I'm going the other way, I'm going to write this as a product. So 2 times 108 is 216. And there we go, we have written it as a single logarithm. That's it, you're done. If it says write as a single logarithm, and you have it as a single logarithm, then you have done exactly what they asked. Huh? Yes. Huh? Okay. Oh, okay. Huh? Megan has her palms up here. Huh? See? Sorry. All right. Let's do it again. All right, so the first thing I'm going to do is I'm going to bring this inside. So I wind up with natural log of 32 to the 3/5 power minus natural log of 4. Now, check it out. I have some choices right now. Let's make good choices. Right, teenagers? Come on. Let's make good choices. I know. It's difficult for you all. There's actually a thing in your brain that's making it complicated for you. Yeah. Yeah, no, it's true. Sorry, side note. So at this point in time, you have a choice to make. You have a choice to make. So 32 to the 3/5 power. I could write that as, remember, the 5th root of 32 cubed, right? I could write that as a radical. I could write that as the 5th root of 32 cubed. But that would cause a lot of writing, right? There's a chance that I could not have to do all that writing if 32 to the 3/5 power is a whole number. Is it? It is. What is it? It's 8. Fantastic. Just saved myself a bunch of work because I made a good choice. I decided to put that in my calculator, see what happens. I decided that it would be a good idea to do it. I didn't do it, but thank you for doing it. I'm going to go ahead and take credit for your work. Get used to it. That's the way the world is. And now I don't have to write the 5th root of 32 cubed over and over and over again. I don't want to do that. So now I'm going to go ahead and write this as a quotient. So I'm going to leave my natural log of 5. And then I'm going to write this as natural log of 8 divided by 4. That's going to become natural log of 5 plus natural log of 2. And then I multiply those, and I get that this is the natural log of 10, and I have written it as a single logarithm. Yeah. Why aren't we adding 5 and 2? Making a natural log of 7? Because the property tells us. Because natural logs don't behave the same way as a normal number, right? This inside of this, right? Because this is actually telling me that e to some power is 5, right? It's not just 5. So I can't just actually add on. So I have to write it as a product. So that's why we have these.
Well, it wasn't natural log, it was just log. Would you multiply the product?
You still would, yeah. You're still going to use those properties of logs, right? So we're going to still use the property that tells us that log of x plus log of y is equal to log of x times y. Okay? So that's a rule that we have to follow every time, and that rule isn't going to change, right? We can't divert from that rule at all. Okay. Let's go ahead and expand some logarithms. Yay, let's expand them. So first thing I want to do is, actually I'm going to work over, no, let's move on to work here. Alright, I'm going to call this natural log of the square root of 5x cubed minus natural log of the squared. So hey, if natural log is log base e, what is natural log of e squared?
1.
Who said it?
1.
It's 2, yeah.
Is that?
2, okay, was it you? You're like I was kind of sure about it. No, and the reason why is, right, this is the same thing as log base e of e squared, right? So remember when we're calculating logarithms, we say e, so what power is e squared? E to the second power is e squared, right? So that's going to become natural log. First thing I'm going to do is I'm going to write this exponent, this radical as an exponent. And then that's 2. Natural log of e squared is 2. Alright? We're going to bring this 1/2 out to the front. And now be careful. A lot of people might try to pull this 3 out right now. Don't do it. Because first we need to separate the 5 and the x squared. This has 5 times, x cubed. So first we have to separate that and write it as a sum of 2 logs. So let's do that. And remember, if we're going to write it as a sum of 2 logs, and the 1/2 was in the front, was the coefficient in the first place, the 1/2 has to be the coefficient of each of these after I break it up. And we just have one step left, and that is now to pull this 3 out, this cube power out. Sorry, my bad. 3, right? If I'm going to pull the 3 out, I'm multiplying, right? When the 3 comes out, it's going to be multiplying the 1/2. So 3 times 1/2 is 3 halves. And that's going to be natural log of x. And we're done. Whoops. Now it. Can't forget that -2. Because -2. We have one more to do, and it looks complicated, but it's actually the easiest one. So this, I'm going to write it as a quotient, so this is natural log of x plus y squared minus natural log of x squared plus y squared. I can't do anything with a sum or a difference inside of my logarithm, because there is no rule that tells me I can break that up. It's stuck that way. Okay? Those are stuck. I can't do anything. The only thing that I can do with this now is I can take this 2 out right here, right? So I can write it as 2 natural log of x plus y minus natural log of x squared plus y squared. And we're done. We did it. You might be asking yourself, what's my homework? That wasn't a question that came up in your mind? That's funny. You don't have time? Okay, I will do a handstand then.
Hurry, we have 1 minute.
Oh my gosh. Your homework, I'm going to put it online.
Okay.
There's going to be 1, 2, 7, 9,
We have to go. Hurry. Oh my
and 8. 1, 2, 7, 8, 9.
Yeah, Corbin.
Come on, Norman.
Oh, sorry.
Corbin!
Fire! I'm just trying to do a All right. So, let me write this down for you. Cool, thank you. Thank you, you too. Okay, you're going to go to so today too. There's like a drop down with a bunch of modules. Just focus on looking at the stuff from module 3. So look at module 3. Because I bet you that a lot of it is really boring, huh?
Yeah, but we did later, like the whole first semester, and we just started part right, so we have to start again.
Okay, you're in algebra 2, right? Okay. All right, we'll get you caught up. It's going to take a little bit. Okay? All right, you're welcome. Oh, yes. Today is a day for you to work on the quiz. Oh, I don't have to stand up and talk to you guys. Oh, class, good grief. I'm sure. And I need to check your last homework because that's missing.
Eureka.
Yeah, it's gonna work. Oh, that's
Should I put that back again?
Oh, sorry.
That was a 1 in 10 shot right there. Yoga with Adrienne was pretty lit, I gotta say.
What?
Yoga with Adrienne was pretty lit, I gotta say.
Yoga?
Yoga.
Oh, yoga.
I'm actually, like, a little tapped out from it.
Crazy.
Hot Pilates?
Yeah.
That's out of hand.
That is, oh my god.
Just go for a run at that point.
No, I was dripping and like my mat was so sweaty, so I was like dripping because I was like so.
No, so when you go to hot yoga or hot Pilates, you take your mat and a towel.
Yeah, I did, but I
Did you put a towel on your mat?
No, put a towel on my mat, but I brought a
No, yeah. Bring a towel for your mat and a towel for
It was my first
yourself.
time. I had no idea.
It's disgusting.
Yeah.
I really think it's gross. I sweat, like I'm a sweater. Like when I work out, I get very sweaty. I don't need more of that.
Probably like 110 degrees.
Yeah, no, that's what they do.
Good morning.
Cleveland High School. Today is Wednesday, February 7th, 2018. This is Stephanie. I'm Renata. And from J3. Please stand for the pledge. I pledge allegiance
To the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. America.
Driver registration silence for their next class is beginning March 5th. If you're 15 or older, you're eligible to drive. Class sizes are limited to the first 16 who sign up early. If you'd like more information, see Coach Allen or 2108. Go to your grade level office or go to the future page to close out the driver's license. Get licensed, get going, get driving. Some teachers would like to thank seniors who have already sent in your videos for this transmission video. And for those seniors who still haven't sent in your videos, hurry to get those videos in before it's too late. The initial teacher will list the window because 1155 for more information. Or upload your video to chsstrokechasers@gmail.com. Teaching today will have a mandatory meeting this Friday from 11:25 for all students. If you'd like more information, see Ms. Fox. Registration for advanced placement testing is taking place through March 16th. Go to Cleveland's homepage and click on the link for more information and sign up. Skills USA will meet tomorrow right after school in Melinda's Rec. Purchase the yearbook before the deadline of March 24th. You can purchase your yearbook at the activities office for $75 or online at yearbookordercenter.com. Use the order number 12975. Tennis trials begin Monday, February 12th through the 14th. Monday and Tuesday times will be from 2:45 to 4:30, and Wednesday will run from 2 to 3:30. You must have an athletic clearance book before you can participate in tryouts. If you have any questions, see Coach McCord. If you're interested in playing golf this spring, then attend a meeting next Monday, February 12th, right after school in Mr. George's room 3103. Physical instruction and concussion protocol are required before you can participate. If you'd like more information, see Coach Georgia at 3103 or Coach Woodrow at 2131. Tomorrow, storm chasers will be DPP for the student montage. You're not going to want to miss it. Keep the senior announcements for Wednesday, February 7th, 2018, and don't forget to check out all our videos and like us on our Facebook page. From all the Texas Sun Center, have a great day, and we'll see you tomorrow at YouTube.com.
Okay, so the normal distribution of it.
The one that's, you know,
Alright guys, see if you work on that case. Yeah, that's right. When I found that workout, first of all, I was like, this wasn't through a workout, there were 45 minutes. Stretching the plan, went through like 45 minutes of workout. Everything was like, okay, let's see how much money yoga with me. And I was like, and it just, did a couple of things and I was like, yeah. Well, I'm actually like, I feel weird today. I feel like, I don't know. Like I tried to do handstand and I didn't have the strength to do it. Like my muscles are all. I have 2 hands. I'm gonna go to the left.
For this, is there
Oh, teach. What? Oh, really? You can actually hold it. Oh, you're going. Just tell me how you. The critical value working the full year. Oh, I can really how it improves everything. So the critical value is going to be is going to be some kind of critical value because you're basically here you're doing a normal distribution, right? It's not you're not using simple, right? For proportions, cool. So for a proportion, we're only using normal distribution. Which means that we're going to get our critical value for last quarter. Then we're looking for 25%. Which means Because it's assuming that you have infinite degrees. You're assuming that there are infinite amount of, yeah, you're assuming that the infinite amount of you're gonna do that for a sample. So if you have a sample and you're wanting to take a confidence interval for the mean of the sample, that's when you use the t distribution. So look how good that is. Perfect. Yeah, the confidence level, yeah, and then the first number up is going to be for a z distribution. Yeah. Yeah. So what's going to happen? What they're actually saying is that n is 36, right? Yeah. But some of that well, so they're saying that, hey, so weird. They're saying actually there were 36, but they only used 20 because only 20 actually respond. I mean, they can adjust it. Right, so they're saying n is going to be 36.
There's really no sound.
Yeah, it's going to be fine. They're going to adjust. N is going to be 36 in that case. Let me look at that. That's my response. Let me just make sure. Wow. Hey guys. Oh wait, 8.1b. Wait, here we go. Sorry. So guys, 8.1 2c. I wanted to talk about it because it's really weird. It is so weird. Did your tutor know the answer? No, it's weird. Yeah, because my instincts say, okay, yeah, just make n36, right? In that case, like, and it's gonna change your standard error slightly, right? It's gonna make it a little smaller. But the solution says that that's not a fair thing to do because what you're doing is taking into account bias that is created by your collection method, and the margin of error only accounts for bias that occurs because of the sample, because of like variation in the sample. So the answer is no, and it's because the margin of error only accounts for variation in the sample, not for variation because of the exact word bias inherent in the data collection methods. Good grief. Okay, the margin of error is accounting for variation in the sample, not variation caused by bias inherent in the data collection methods. As a freaking weird question, okay? Yeah, that was a phone call one. I used my phone call just now. No. Oh. Okay. The margin of error only accounts for variation in the sample, not variation created by bias inherent in the data collection methods. That was weird. So weird. Yep. Oh, one moment. Let me just. I gotta grade this, which is gonna be a pain in the butt, but alright, it needs to be done already. I need to prepare myself here. Oh, darn it, I need to check the homework. It's happening right now. And then I am coming in just a second.
For this one, finding the C-star, how do you find C-star?
For 3, you want to test me?
Or a different one?
Yeah, let's see here. So you're going to use is there, yes, we need to find a critical value. But remember, it's you're going to use, oh, you solved this, okay. I would use a different approach. Let me get over there. Let me get my pen ready. Alright, so our information we have on this is that it is or okay, so since we're using sigma, we know we're going to be using sigma. I don't know if you were right. Okay. So C star is going you guys need a new one? Okay. So I'm going to go to 99%, so that's going to be 2.5. Yeah, if you're assuming that it's a normal population, and if you're given the actual standard deviation, then you're going to assume the population. So now we're going to say 1. And it says at least 1.
No more.
Okay, so that can be so our margin of error is let's see, our standard deviation here is going to be sigma. And this is what we're talking about.
It doesn't make sense. Like, I was literally carrying,
Okay, you guys have that one part from last time. Sorry. I know, it's chapter 7. I never checked chapter 7.
yeah, and that's the fucking 35 rules. Yeah, makes sense. Yeah, that's not. I was guessing like, yeah.
I can also check it on Friday. I kind of wanted to get it. I won't be there up there. Do you have it like on campus? I'm sorry, it's talking about Oh my gosh.
Oh,
I
Only if it's by a negative. So yeah, when I did the first one, I was like, good thing this is positive, else we have to remember something totally different. Right? I'm going to just take your word for it, we had it, and then you can like to me. So I think that's it should bump you guys up. No, the good thing is, the beginning of this, you still have so much more to do.
that would be good. I'm definitely trying.
You just want to graduate? Good luck with that. Let's take it. Okay.
Oh, I was right.
So we're looking at the standard error for a population of 7, right? So right, except for you need to multiply it by critical value. We have this here. I'm gonna walk away. Yeah, right. And then, so our here. Now for a population
There you go, there you go.
So yeah, so I'm saying only thing for history. And then you have it there, you say if it's multiplied by 1.9. Anyone want some calculator? Oh, I know. It's not.
Yeah, the box.
She's saying that she calculated this to be point.
I didn't get that.
Sweats.
Let me give you guys a little.
You guys need calculators? Hey, you know what, guys? If you ever need them, just go ahead and grab them. We're good like that. Yeah, try it again. So, calculator. Calculator? Anybody want a real calculator? Yeah? Yeah, I'll go. We're on it. Or B, let's see if they can. Sorry, dude. Give me one while Okay, so in this, it starts with sequence You want to draw that? You guys for 4B. For 4B on that's 3.8.3, right? You've got to show that the data is good enough for you to assume normality. So that means you probably have to draw the graph. Yeah. Let's see. Let me see if the solution wants you to draw it out. If you wanted to be really, really, really right, that would be the way to go. To actually just draw a little graph of the distribution.